Hi, and welcome to this third video on graphing quadratic equations from standard form. Okay, so in this video we're going to look at one that's slightly more complicated. Okay, so we have y is equal to negative 2x squared minus 9x plus 5. Okay, so let's identify our coefficients first. So a, in this case, is negative 2, b is equal to negative 9, and c is equal to 5. So let's find our axis of symmetry using the equation x equals negative b divided by 2 times a. Okay, so negative 9 divided by 2 times negative 2, and so that reduces to 9 over negative 4, which is about negative 2.25. Okay, so now we're going to use that axis of symmetry. So this x value, so an x value of negative 2.25, and we're going to plug it into our equation in order to find that y, that missing y value for our vertex. So f of negative 2.25 is equal to negative 2 times negative 2.25 squared minus 9 times negative 2.25 plus 5. Okay, so take a minute and go ahead and calculate that using your calculator and find out what that exact y value is, and then we'll graph it. Okay, so you should have gotten that y, or f of x, would be equal to 15.125. So f of negative 2.25 is equal to 15.125. And another way to write it is as a point, so negative 2.25 comma 15.125. So 15.125 is going to be a little big. So again, we're going to go in twos on our vertical axis. Our x-axis is still the same, 1, 2, 3, 4. But we're going to go in twos on our vertical axis. So I'm going to go ahead and relabel that. So that's going to be 2, 4, 6, 8, 10, 12, 14. It looks like I'm going to have to add another row up here. Extend my y values a little bit over. Okay, so it looks like I'm going to run into my equation there, but I'll work over it in a different color so that I don't have to erase anything. Okay, so first of all, we should have graphed our axis of symmetry, which we forgot, but let's go ahead and do that. So that's going to be negative 2.25. So before we had like negative 2.5, well, this is going to be negative 2.25, which will be halfway between negative 2.5 and negative 2. So that one will be about here. So it's going to look a little closer to the x value of negative 2, but not quite on it. Okay, so that's what that one looks like. And we can go ahead and write our equation x equals negative 2.25. Okay, so now let's graph that vertex, which is way up here actually. So it's 15.2. So I'm going to go ahead and erase this equation because I don't really need it anymore. And it's just going to be in the way of my graph. And so I'm going to go ahead and get rid of that. All right, so let me extend my line over just a little bit again. Oops, that one should be right there. So let me erase that. All right, there we go. Okay, so I'm going to graph this in, let's say, we'll try green. So negative 2.25 and then 15.15 will be pretty close to 15. So that one's going to be about right there. And so remember that it's going up in twos and not ones. Let me put my line back. So it's about there. Okay, so then let's find our y-intercept. Well, remember that it's in the form y equals ax squared plus bx. And so if we go back up and look at our equation, it looks like our y-intercept is a positive 5. So our y-intercept is 5. And there's nothing to multiply out. It's pretty much in standard form. So y is equal to 5, or the y-intercept. And we can also write it as 0, 5. Okay, so if we go down here and graph that point, that's going to be between 4 and 6. That's 5. And then remember, we can also use symmetry in order to find out where the other point is going to be. So negative 2.25, if we go 2.25 more to the beyond the axis of symmetry, we can basically take 2.25 and double it, or negative 2.25 and double it, so times 2. And that will be 4.5, so that's where we should end up. So this is 1, 2, 3, 4, and then 4.5 will be right here. And so if we're at the same level, then 4.5 away should be at the same level as our y-intercept, okay, because the function is symmetrical. Okay, so now let's go ahead and find our x-intercepts. All right, so our x-intercept is, we can find out if we have any and how many we have by b squared minus 4 times a times c. So b squared, we found that the b was -9. So -9 squared minus 4 times a, which was -2, times c, which was +5. Okay, so let's graph that. That's going to be 81. Sorry, let's calculate that. 81. And then -4. -4 times 2. Uh-oh, what happened to my sheet? Let me go back to, looks like I lost my page. Okay, there we go. All right, so -4 times -2 times 5 will give me +40. So that's going to be plus 40. And so let's calculate that. 81 plus 40 is 121. So again, b is greater than 0. And so we have two x-intercepts. Now let's find out what they are. Using the quadratic formula, x equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And so negative, we have b, which is -9. So plus or minus the square root of -9 squared. And actually, I don't need to do that again because I've already done it using the discriminant. And so I can actually take this 121 and put it over here. So the square root of 121, all divided by 2 times -2. And so that's going to be 9 plus or minus, looks like 11, all divided by -4. So let's split that up. And so my x value can be x is equal to 9 plus 11 divided by -4. And so that would give me 9 plus 11 is equal to 20. So 20 divided by -4 would be -5. And x would also give me 9 minus 11 over -4, which would be a -2 over -4. So 9 minus 11 is -2. And so that would actually give me a +1/2. So my x-intercepts are going to be -5, 0 and 1/2, 0. Okay, so let's go ahead and graph those points. -5, so that's 1, 2, 3, 4, 5. So that would be here. And then 1/2 would be here. Okay, so we can see that our parabola still looks symmetrical. So let's go ahead and connect all those points. Okay, so let's label the important ones. 0, 5, 1/2, 0. And then -5, 0. And then, of course, the vertex of -2.25, 15.125. All right, so I have all of my points, and if you want to label this extra one here, of course, that would be -4.5, 5. Oh, I can barely write it. Oh, there it goes. Pen is very sensitive. Okay, I hope this video has helped you. And we can go on to another one. Let's actually just move down to the next one. First of all, we need to decide, I forgot to ask whether it's a maximum or a minimum. We can see that this one is turned down. So in this case, this would be a maximum. Okay, so now let's look at another case. We have 2x squared plus 6x plus 4. So a is equal to 2, b is equal to 6, and c is equal to 4. So I'm going to use my axis of symmetry. X equals -b, all divided by 2 times a. And so that's equal to -6, all divided by 2 times 2. And so that's going to be -6 over 4. And we can reduce that to -3/2, which is -1.5. So I can go ahead and plot my axis of symmetry at -1.5. So that would be right smack in the middle of 1 and 2. Okay, so now what we're going to do is use that, remember, -1.5, comma, whatever the y value is, that will give me my vertex. So let's go ahead and find it. F of -1.5 is equal to, we have 2 times negative 1.5 squared plus 6 times negative 1.5 plus 4. Okay, so go ahead and take a second and calculate that. Okay, it looks like we got f of negative 1.5 is equal to negative 0.5. Okay, so that one's pretty small number, pretty close to the axes. Okay, so negative 0.5. All right, so I'm going to go ahead and plot that point. Negative 0.5 is here. All right, so then now let's find the y-intercept, and it looks like the y-intercept in this case, c, will be equal to 4. So 4, 1, 2, 3, 4. And then, of course, remember that I can come on the other side, the same distance, and find the other point. All right, so now I want to find the x-intercepts. I have the y-intercept. We know that that one is equal to 0, 4. All right, so let's go down and find the x-intercept. So we have b squared minus 4 times a times c. And so b was 6, so 6 squared minus 4 times a, which we found to be, let's look back at our equation, 2. And then times 4. Yep, times 4, which is 4. Okay, so we have 6 squared minus 4 times 2 times 4. And so when we get that, we get 36 minus 4 times 4 is 16. And then times 2, or 4 times 2 is negative 8, and then times 4, that would give us 32, so minus 32. So again, b is greater than 4, not much greater than 4, but it's still greater than 4, and so we should have 2 x-intercepts. Okay, so let's go ahead and find out what those are. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Okay, so negative, it looks like b was 6, plus or minus the square root, and we got a 4, all divided by 2 times 2, because a was 2 in this case. Okay, so let's simplify that. We get negative 6 plus or minus, well, the square root of 4 is 2, divided by 4. So let's split our x's up. So x can be negative 6 plus 2 divided by 4, and x can be negative 6 minus 2 divided by 4. So negative 6 plus 2 is negative 4 divided by 4. And so x equals negative 1. And then x equals, get negative 8 divided by 4. And so that's actually negative 2. So x equals negative 1 and x equals negative 2 are our x-intercepts. So negative 1 comma 0 and negative 2 comma 0. So let's go ahead and graph those. Negative 1 comma 0 will be here, and negative 2 comma 0 will be here. So what we get is kind of skinny function that passes up like this. All right, but nevertheless, we still have a parabola that's open upward, so this will be a minimum value, a minimum point. So we can go ahead and add that there. It's a min, and it's at negative 1.5 comma negative 0.5. That's our vertex, and it's a minimum. Okay, let's label our other points. So we got negative 1.5 comma negative 0.5, and then we have negative 1 comma 0, and then we have, it looks like negative 2 comma 0, and then we have 0, 4, and then we have 3, 4. Okay, so there are all of our important points on our parabola. So just be careful with your math and make sure that you're plugging in your integers and everything correctly, and then you should be good. Alrighty, thank you. Hope this video has helped. See you in the next one.